Hello, in this video, we will do some harder examples of ASVAB math problems. So yes, these are some of the harder examples of the ASVAB math problems. So let's begin. So we'll start with question one. Jamie just bought two boxes. The first box is a square with each side measuring 10 units and it is 4 units high. The second box is rectangular and has twice the volume of the square box. If the height of the second box, if the height of the second box is 5 units and the width is 10 units, what is the length? What is the length of the second box? Okay, so what I would do in this problem is we're dealing with volume. So we have two different boxes and we are dealing with two different volumes. So let's call, uh, yeah, we have volume, we could do volume one, and then we have volume two, right? Two different boxes, two different volumes. So what is the formula of a box? I mean, the formula of a volume, it is basically length times width times height. So in the first box, they said it's specifically each side is measuring 10 units and its height is 4. So that means the length is 10, the width is 10, and the height is 4. And when you put it all together, you're going to get 10 times 10 times 4 is 400 unit cubed. Now let's do the second box. So they're asking, the question says, what is the length of the second box? What is the length? So they're not asking for the volume. They are asking for the length. So volume is length times width times height. Um, they do tell us the volume for the second box is 800 because, well, not really. They tell you that the second volume of the box is twice as large as the first one. So it's really 400 times 2, which is 800. And then we don't know what the length is. That's what we're trying to find out. Do we know the width of the second box? Yes. They're saying that it is, if the height is 5 and the width is 10. So that means, yeah, width is 10, the height is 5, and you got your almost got your answer. So 10 times 5 is 50 L, and then you have 800. And then you solve for L by dividing both sides by 50. And you get length is 16 units. Okay, so that is the length of the second box, 16 units. And that wasn't too bad. Well, it was can be a little bit difficult when at first, but just read it and then use what you know. Okay, let's move on to question two. So question two says, what is the cost of mailing a package that weighs 2 pounds and 3 ounces if the cost is $1.50 plus 0.05 cents for each ounce over 6 ounces? So it is kind of like a linear equation problem. The linear equation is y equals mx plus b. Do we know our m and do we know our b? Yes. Our m is, it says it's like 5 cents for each ounce over 6 ounces. So m is like our uncontrolled cost. So our m will be 0.05x. And do we have a starting cost? Yes. Um, um, it starts at $1.50. Okay. Now, what do we put for X? Yeah, what do we put for X? So we have a box that weighs 2 pounds and 3 ounces. Now, if you recall, our X should be all in ounces. Okay, so because it says for each ounce over 6 ounces. So imagine you have this box that weighs 2 pounds and 3 ounces. Okay, we want to know the cost after 6 ounces. So let's convert this 2 pounds and 3 ounces and all in ounces. So that's pretty simple, right? All we got to do is convert pounds to ounces and then add three, and you got your total amount of ounces. How do we convert 2 pounds into ounces? Well, set up as a fraction. Put pounds on the bottom because you want to get rid of the pounds, and then ounce on the top. What is the relationship between pounds and ounces? For 1 pound, there's going to be 16 ounces. And then multiply across, so 2 times 16 is 32 ounces. And then on the one, it's just one. Now, you want the total amount of ounces, so it's 32 plus 3, which is 35 ounces. Okay, now do we put 35 ounces? No, not yet. It says for this is how much it weighs in total ounces. So our cost is after over 6 ounces. So what you got to do is subtract um 6, right? So you're gonna do 35 minus 6, which is 29 ounces. Okay, then you may put it into this equation. So y of 29 is equal to 0.05. Replace x with 29 plus 150. And you get, uh, remember we can't use a calculator, so you need to know how to multiply. Um, what is 29 times 0.05? That should be a dollar 145, right? So you can set up like this, right? Remember, we don't line the decimals, so it's 9 times 5 is 45. 9 times 4 is 0 plus 4. 9 times 0 is 0. Placeholder, 5 times 2 is 10. Carry the 1. 2 times 0 is 0 plus 1. 2 times 0 is 0. How many total decimal places? There's a 2, 1, 2, so it's 145. So it's 145 plus 150. And you do have to line up the decimals when you're adding and subtracting, right? It's 5, 9, and 295. So your total cost after 6 ounces is going to be $2.95. Okay, so a little recap. I know this is related to a linear equation. I converted our weight all in ounces, and then I subtracted it from 6 because it's 35 ounces, obviously larger than 6. And I subtract that by 6 and I get 29 ounces. And then I plug in 29 to the linear equation y equals 0.05x plus 115. Okay, let's move on to the next one. Okay, question 3 says Sean purchased a shirt for $22.05. If this includes a 5% sales tax, what is the actual price of the shirt? So you got to ask yourself, is this going to be larger? They're asking you what was the actual price of the shirt before the sales tax. So do you think this is going to be more than 22.05 or less than 22.5? It's going to be less than 22.05, right? Because this includes a 5% sales tax. So it's the cost before the sales tax. So technically, you could really just do 5% of 22.05 and then convert 5% as a decimal. So this would be 1, that'd be 0.05. And you get 1.1025. Then all you got to do is subtract this from the original cost. So if you th this isn't a fill in the blank, you will get multiple choice. So you're going to get an answer that's really close to it, right? When you do that, you get like 20. It comes out as 20.9475. Now, the correct answer is 21 because they rounded to the nearest full dollars. And as you can see, you can use this answer and you can see that it rounds to 21 and you'll see that one of the choices is 21 and you would pick that one, right? Okay, that's one way you could do it. The other way is you can set it up as an equation. You can say OP, which really stands for original price, plus taxable amount. I'll call it TA. So TA stands for uh, taxable amount times it by original price equals total price. Okay. So what is the original price? We don't know. We'll call it X. Plus the taxable amount, it's really 5%. Times it by the original price, we don't know. We'll call it X. Equals your total price, and that was $22.05. And then if you kind of clean this up a bit, this is going to be X, or you could say 1X, up to you. How do we convert percentage to decimal? Just move it two places to the left. So that's 1, 2. So that'd be 0.05x equals to 22.05. And then clean this up a bit. So what's 1x plus 0.05x? And that is 1.05x equals to 22.05. Solve for x by dividing both sides by 1.05. 1.05. And you get, so remember, so if you need to know how to divide decimals, so how do I do this? So you're gonna do your box because you can't use a calculator. So the numerator goes inside, the denominator goes outside, and you can never have a decimal inside here. It's okay to have decimals here, but not here. So what you have to do is move this two places to the right, and then you're gonna move this two places to the right. So your new, it's gonna be 105 and then 22.05 period decimal. And then how many times does 105 goes into 220? About twice, because 2 times 105 is 210. And then 220 minus 210 is 10, then bring down the 5. How many times the 105 goes to 105? 21. So as you can see, you get exactly $21. Okay, so either way works. It's really up to you how you want to do this. Psst. Okay, let's move on. Okay, question 4 says, how much will it cost to put hardwood floors in a room that is 15 feet long and 12 feet wide if the hardwood floors cost $44.25 per square yard? So imagine you have this, like um this room, like a rectangular room, right? And they're specifically saying it's 15 by 12 or 12 by 15. So this could be 15 feet, and then this could be 12 feet, right? And they want to know how much it would cost to put hardboard floors, right? That costs $44.25 per square yard. So what you got to do is notice that it's square yard. You got to convert feet into yards. So that's the first thing that we're going to do. We're going to convert everything into yards. So let's start with 15 feet. So 15 feet times feet on the bottom and then yards on the top. Um, for what's the relationship between yard and feet? For 1 yard, there's 3 feet. And then if you like multiply across to 15 over 3, just 5. So really 15 feet is the same thing as 5 yards. And then do the same thing with feet. So 12 feet and then feet on the bottom and then yard on the top. You know that for 1 yard, there's 3 feet. Like 12 times 1 is 12. 1 times 3 is 3. That is 4 yards. Okay. Then I would take the area. The area is length times width. So it's 4 by 5. What is it? Yeah, 4 by 5, which is 20 yards square. Okay. Now, the total cost, do we divide this by 44.25 or multiply it? Yes, we technically multiply it, not divide. So it's 44.25 times by 20. And when you do the algebra, um, you're going to get 885. Okay. Okay, so go ahead and redo this problem without a calculator. And yeah. Yeah, so go ahead and just, if you need to stop the video, go ahead and pause the video. Okay, question 5. I like, these ones are always the hardest ones. The steamboat going uphill, downhill, and all that stuff. Those are the hardest, in my opinion. So question 5 says, a steamboat can go twice as fast downstream as it can go upstream and three-fourths as fast upstream. It can go 30 miles per hour downstream. And then the question says, then how long will it take to travel 40 miles in calm water? Okay, so imagine a steamboat, right? You're on a steamboat, or even just any kind of boat. It can go several ways. You can go you can go upstream, which requires more speed or more work, right? And the steamboat can also go downstream, which technically you go faster, right? Because you're going downstream. And then you also have what's called calm water, where it doesn't really move, right? The current doesn't really move. Um, so they're asking you how long or how the time will it take to travel 40 miles in calm water. So what we're going to do is when if they're asking for speed, distance, or even time, you know you're going to use formula distance equals rate times time. Okay. And they're asking you how long. So they're asking you for a time unit, time. So we have to isolate t by itself. So I have to get rid of this r. So the only way to get rid of this r is divide both sides by r. And you get t equals distance over rate. Now, do we have a distance? Yes, our distance was given as 40 miles. Do we have the rate? No, we do not have the rate. We know the rate, we'll have our time. So this is where it can get really tricky. So if you have to read it again, go ahead. So a steamboat can go twice as fast downstream. That kind of makes sense when you're going downstream. So we have calm, we have going up, and we have down. Okay. So for calm, we'll call it X because yeah, we don't know. Um, for up, okay, it specifically said a steamboat can go twice as fast downstream as it can go upstream and three-fourths as fast upstream as it could go in calm water. So what that means is it's going to be three-fourths of the calm water. We don't know what the calm water is. We'll call it X. And then downstream, you're going twice as fast as up, right? You're going twice downstream, you're going twice as fast as upstream. So it's 2 times 3/4 X. Okay. So X for calm is X. For going upstream, they're saying it's three-fourth as fast as calm water. So that's why I did three-fourths of X. And then downstream, it's twice as fast as going upstream. I know that's confusing. So if we know what X is, we can find our rate, right? So do we know what else? Yes. They specifically said when going downstream, it can go 30 miles per hour. So here's our downstream, which is 2 times three-fourths X. Let's clean that up a bit. So 2 times three-fourths X, that's going to be 6X over 4. And then we can set that to 30 because it says it can go 30 miles per hour downstream, right? Now we can solve for X. So what I would do is cross multiply. So it's going to be 6X equals to 4 times 30 is 120. And then solve for X by dividing both sides by 6. And then 120 divided by 6 is 20. Okay, we found our rate. This is our rate. So rate, this is going to be 20 miles per hour. Okay, so we can find our time now, right? So our time is distance over rate. So our distance was 40 miles. Our rate was now 20 miles per hour. Now 40, 40 divided by 20 comes out nicely as 2. But if you look carefully, our units will become hour. How did this whole thing become hour? Because we had kind of have like a complex fraction. You have mile, so this is like your numerator. This is like your denominator, right? You have miles, and then over 1 divided by miles per hour. And then if you cross multiply, this is going to be miles per hour. And then over here, this is going to be miles. And then you're left with hours. So that's how you got hours. Okay. So our time is 2 hours. So if you have to redo that problem again, go ahead. Because it's a bit tricky. Okay, let's move on to 6. Okay, question 6. Tiling costs 255 per square foot. What is the cost to tile a kitchen whose dimensions are 4 yards by 5 yards? So imagine you have this room, this dimension, and it's 5 yards by 4 yards, right? And it costs $2.55 per square foot. So the key is it's in square foot. So what we got to do is convert everything to foot. So let's start with 5 yards. So let's convert 5 yards to foot. So that would be yards on the bottom and then foot on the top, feet. What is the relationship between feet and yards? For 1 yard, there's 3 feet, right? And then if you multiply across, that's going to be 15 feet. So this converts to 15 feet. Now do the same thing with the 4 yards. So 4 yards times yards here, and then feet on the top. So for 1 yard, there's 3 feet. It's going to be 12 feet. So 4 yards is going to be 12 feet. So what I'm going to do is we're going to find the area. So area is length times width. So it's 12 by 15. And 12 by 15 is 180. And then to find the total cost, we simply multiply 180 by 255. And what you get is $459 as your final answer. Okay, so yeah, no, that wasn't too bad. Okay, let's move on to 7. So question 7 says the pet store had 6 puppies selling for $1.104 each and 12 kittens selling for $24 each. Today, only 2 puppies and 8 kittens were left. In dollars terms, what was the ratio of the sales of puppies to kittens? So when they say ratio, you can put it as like, for example, this is a ratio A to B, or you can also say A to B, or you can also say A over B. They all mean ratio. So ratio can be expressed as a 2 colons, or A to B, or A over B. Okay? So yeah, the first thing that I would do for this problem is let's label our variables. So we're dealing with puppies and kittens, so we can say P equals puppies and K for kittens, right? Okay, then what I would do is figure out how I'm going to figure out how many puppies are left. So it said that we originally had 6, and then today only 2 puppies. So you're gonna do it's 6 minus 2, which is 4 puppies. So there are 4 puppies left. And then do the same thing with kittens. So we originally had 12 kittens, and then we're left was 8 kittens. So 12 minus 8 is 4. So you have 4 kittens that are left. Okay, so we have 4 puppies and 4 kittens are left. So they say puppies were sold for 104 each. So you could say 4 times 104, and that gives you 416. And then do the same thing with kittens. We had 4 kittens left, and they were sold for, oh, sorry, no, my bad. Uh, let's leave it like this. So they want to know the ratio. What was in dollars terms, what was the ratio of sales of puppies to kittens? So for puppies, it was $4. We had 4 puppies left, which at costing 104 each. And then I'm gonna put the colon. And then for the kittens, so this is puppies. And then for the kittens, it was we had 4 kittens left, and then each kitten was sold for $24. Okay, can we leave it like this? No, we can get rid of these fours, so we can divide both sides by 4. And I get 104 to 24, right? And can we leave it like this? No, I think we could reduce it one more time by 2. So we can divide this by 2. So what is 104 divided by 2 is 52. And then 24 divided by 2 is 12. And can we leave it like this? No, we can divide this by 2 as well. Okay, so 52 divided by 2 is 26. Colon 12 divided by 2 is 6. Can we leave it like this? No, we can divide it again by 2. So that's going to give me 13 colon 3, or you could say 13 to 3. Right? Either answer works. Okay, let's move on to the next question. Question 8. Question 8 says, if the ratio of the sides of two squares is 3 to 1, what is the ratio of their perimeters? Okay, so imagine you have two squares, 3 to 1. 3 to 1, what that means is the three and the 1 represents their side lengths. So you have a square, two different squares, right? And by the way, what do we know about squares? We know that in a square, all sides are the same. Okay. And what else do we know? The first square has a side length of 3, and then the smaller square has a side length of 1. Now, because we said squares are all the sides are the same, so you can put 3 here, 3 there, 3, and then 1, 1, 1. And what else do they want? They want to know what is the ratio of the perimeters. So ratio means semicolon or fraction. And what is the perimeter? Basically you add up all the sides, but in a square you can say 2L plus 2W or 4S. Or yeah, you can do 4S as well. Yeah. So in the first square, what is the perimeter? It's just 4 times 3, which is 12. And then in the second square, it's going to be 4 times 1, which is 4. Okay, so you get 4 times 3 is 12, and then semicolon, because that means proportion, right, to 4. And then you can reduce this by 4. And then 12 divided by 4 is 3, and then colon 1. Okay, so your ratio is 3 to 1. Okay, that wasn't too bad. I mean, it looked bad, but it wasn't. Okay. Okay, here's another perimeter in a square. So question 9 says the perimeter of a square and a rectangle are the same. If the rectangle has a length of 20 centimeters and a width of 12 centimeters, what is the area of the square? So you have these two different shapes, right? You have a rectangle, and a square. Okay. So imagine you have these two shapes. You have a rectangle, and then you have a square. Okay, what do we know about a square? We know that all sides are the same. What do we know about the perimeter of a square? It's basically 4 times s. And then what do we know about the perimeter of a rectangle? It is not 4s. It is basically 2L plus 2W. Um, and what about area? What about the area of a rectangle is length times width, and then the area of a square is basically side times side, or s squared. Okay, what do we do next? They specifically said that in this rectangle, it had a length of 20 centimeters, and then this has a length of 12 centimeters. That was given, right? What are they asking? They're asking you, what is the area of the square? Okay. And they're saying that the perimeter of a square and a rectangle are the same. So this perimeter is equal to this perimeter. So let's find the perimeter of this rectangle. It's basically 2 times L, which is 2 times 20, plus 2 times W, which is 2 times 12. And you get 40 plus 24. So my perimeter is 64. The perimeter of this rectangle is 64. Um, do we know the perimeter of this? Well, not really. Well, kind of, but not really. We know that each side is S. So the perimeter is 4 times S. So they're saying that this perimeter equals to this perimeter. So in this perimeter, or the perimeter of the rectangle, it was 64. And the perimeter of a square was 4S. That's all we know. And we can find our S by dividing both sides by 4. And you get S equals 64 divided by 4 is 16. So we just found the side of each square, which is 16. What are they asking you? What is the area of the square? Now we can find the area of the square. So the area of a square is S squared, and we know that each side is 16. So 16 squared, which is going to be 256 centimeters square. Okay. Yeah, not too bad. Okay, let's move on to the next one. Question 10 says, a photograph was reduced to a width of 15.6 centimeters using a scale factor of 3 to 2. What was the width of the original photograph? So a photograph was reduced to a width of 15.6 centimeters using a scale factor of 3 to 2. So the key is when they use the term scale factor, I know I'm going to have to do some kind of proportion. The question says, what was the width of the original photograph? So this is how we're going to set it up. We're going to set it up as a proportion. And how are we going to set it up? So they're saying that, what was it? Yeah, we're just saying. So we had an original, and then we had a reduced. Okay. It said a photograph was reduced to a width of 15.6. So you could put 15.6 here, and then do we know the original? No. We'll call it X. And then they're also saying that there's a scale factor 3 to 2. So that means, so wait, this has to be original, and then this has to be reduced, right? So the scale factor 3 to 2 is basically saying 3 is the original and 2 is the reduce. And basically to solve for your original, or X, you basically cross multiply. So 2 times X is 2X equals to 3 times 15.6. And that's going to be 2X equals to 3 times 15.6 is 46.8. And then divide this by 2, and you get 23.4 centimeters. Okay. Yeah, that's that one. Let's do question 11. So question 11 says Shirley has a small rectangular garden plot that has a 24-foot perimeter. The width of the garden is exactly one half of its length. What is the area of Shirley's garden in a square feet? Okay, so imagine you have this rectangular garden, right? Here's your length and here's your width. So they're saying that the width of the garden is exactly one half of its length. So you can replace W with one half L, and then we don't know what L is, so we'll just call L as L, right? What is the area of Sherry garden in square feet? So what else do they tell us? That they say that the per meter is 24 foot. So we're gonna have to use the per meter formula. So per meter is 2L plus 2W, right? So you can replace this P with 24, and my length is L, and then my width is one half L, right? So this is going to be 2L plus 2 times one half L is the 2's cancel, so you're left with L. The 2L plus 1L is 3L, and then solve for L, so you're going to divide this by 3. And I get 24 divided by 3 is 8. What is the width? Now we can find the width, which is 1 half times L, which is 1 half times 8. 1 half times 8 is 4. Okay, so now we know the area. So the area is length times width. My length is 8, and my width is 4, just 32 feet squared. Okay, that is question 12. Okay, this one, it says the price of salmon at a fish market is $5.40 per pound. This is 150% it costs at a supermarket. How much would it cost a pound at the supermarket? So 540 is the markup price of 150%. They want to know what the cost before the markup. So is it going to be smaller than 550 or larger than 550? Well, if this is the markup, without the markup, it's definitely going to be less than 540. So you know it's going to be less than 540. So we can set it up like this. We can do X, which represents the cost pound, times it by the markup percentage, which is 150%, equals to the cost of the fish market at 550. I mean 540. And then we know that 150% would be expressed as a decimal as 1.5 times it by x equals to 540. And then divide this by 150. And you should get, you can get rid of the zero. So it's really 5.4 divided by 1.5. Move this one to the right. So it's really 15. And then this is 54. Line up the decimal. How many times is 15 going to 54? About 3. So 15 times 3 is 45. 54 minus 45 is 9, 10, 9. Bring down 0. How many times does 15 go into 9? 90, about 6. And then 15 times 6 is 90. So it's 360. So it would cost 360 per pound before the 150% markup. Okay. Okay, this one, 13. Yeah, 13 is it's very similar to the one going downstream, downstream calm water. It's very similar to that. So you know you're going to use the formula distance equals rate times time. So question 13 says a train goes twice as fast as downhill as it can go uphill, and two-thirds as fast uphill as it can go on level ground. If it goes 125 miles per hour downhill, how long will it take to travel 45 miles on flat land? Okay, so imagine you have this train, right? And a train can go uphill, which technically is less speed, right? You're using more force. I mean, I don't know. I don't know if it's more force, but when you go uphill, you work harder, right? When you go more slower. And when you're going, a train can go downhill. And when a train goes downhill, you're going faster, right? You're going faster, more speed. And then a train can also go completely flat. Okay. So the question says how long will it take to travel 45 miles on flat land? So they're asking you for how long. So they're asking for time. So we said that we always use distance times rate times time when we're dealing with these kind of problems. And if we're trying to solve for time, we gotta get rid of this R. So to get rid of that R, you're gonna divide both sides by R. You get time equals distance over rate. Okay. Do we have a distance? Yes. We do have a distance of 45. 45 miles. Whoops. Oh man. Yeah, our distance is 45 miles. Do we have a rate? No, that's where it can get tricky. So we have these three scenarios. You can go uphill, you can go downhill, and you can also go flat. Okay. So downhill, it's what did they say about downhill? Um, it goes 120 miles per hour downhill. Right. So you can say 120, and then what else do they say? They say that uphill. Wait, what else do they say about downhill? A train goes twice as fast as downhill. A train goes twice as fast downhill. So we're gonna set this. Wait, so downhill. Whoops, I made a mistake. I did uphill. So downhill, it specifically said it goes 120 miles per hour, but it also says it goes twice as fast as downhill. So you're gonna say 2x, right? Equals to 2x. And then for um uphill, wait, did I do this right? No, a downhill it's 120, sorry. And then uphill, it's going to be 120 equals 2x because it says uphill, it's two times. A train goes twice as fast downhill as it can go uphill. So I'm going to say 120 equals 2x. And what about flat? And then it says two-thirds as fast uphill as it can go on level ground. So it's going to be 230, two-thirds x. Um, Wait, I think we can solve for x now. So you're going to divide this by 2. So you get x equals 60 miles per hour. And for the flat, so we're going to say two-thirds. So two-thirds of x is equal to 60. So we're trying to find the speed of flat line. So that's why I call this x, because we don't know, yeah, we don't know what the speed is, but we do know it's two-thirds of this unknown speed equals to 60. And then you can solve for x. And how do we get 60? We got it from 120 equals to 2x. And if you divide this by 2, you get 60. And then what I would do next is cross multiply, or we can multiply both sides by the reciprocal of 2/3, which is 3/2. So this cancels. You're left with x equals 60 times 3 over 2 is 180 over 2, which is like 90 mph. Okay, now we can find our time. So our time is distance, which was given as 45 miles. And then our time is 90 miles per hour. 45 divided by 50 comes out nicely as 0.5. And then our unit should be in hours. Okay, so my time is 0.5 hours, or one half hour. Okay, let's move on. So question 15 says, a pet store. Oh, I don't know. Let me move up. Oops. So question 15, a pet store owner set the price of a bag of cat food at 50% above the cost. When it did not sell, the price was reduced to 20% to 12. What was the cost of the store's owner on a bag of cat food? Okay, so that's confusing. A pet store owner set the price of a bag of cat food at 50% above the cost. And then when this cat food did not sell, the price was reduced to 20% to 12. What was the cost of the store owner on a bag of cat food? So they want to know what was it cost, like the original cost. Yeah, so let's label our variables. So we can say we can let C equals original cost of the bag of cat food to the store owner. Step 2, we want to know the price of the initial, which is cost plus 50% of cost. So that's going to be C or 1C plus 50% is the same thing as 0.50 C. And when we put that together, 1 plus 0.5 C is 1.50 C. So this is the price of the initial. And then you're going to apply the price reduction. So the price of the final is basically 100% because it was reduced to 20%. So that's like saying 100% minus 20% is the price of the initial. Times it by the price of the initial. And 100% minus 20% is 80%. And then the price of initial, which we said was 1.50 C. And then 80% as a decimal would be like 0.80 times it by 1.50 C. And when you multiply that out, you get 1.20 C. And we don't know what C is, but that's one of the choice. So my price for the final is 1.20 C. Okay, so that is the choice, and that's our final answer. Oh, we can solve, sorry. There's also, you can find the cost. You can find C because they said that it was when the price was reduced, it was $12. So you can say 1.20 C equals to 12. And then if you divide this by 1.20, you get C equals to 10. Okay, let's move on. Okay, 16 says aviation gasoline weighs 45 pounds per feet cubed or 6 pounds per gallon. How many gallons are there in 10 feet cubed of aviation fuel? So I know this sounds confusing, but it's not. It's just a proportion problem. So we're going to set it up like this. Two fractions, and they're asking you how many gallons are there in a 10 feet cubed of aviation. So that's a big clue what your units are going to be. So your units could be gallons. You could put gallons on the top, and then on the bottom, you could do feet cubed. Okay. So they're saying how many gallons are there? How many gallons, so that's our unknown, are there in a 10 feet cubed? And then somehow we have to have a gallons in a feet cube, but they don't give it to us. Well, they kind of do. It says aviation gasoline weighs 45 pounds per feet cube or 7 pounds per gallon. So basically you divide those two values. So, and you'll see when you divide these numbers, 45 and 6, the units will become gallons per feet cubed. So if you don't believe me, I'll show you. So it would be 45 pounds over feet cubed divided by 6 pounds per gallon. So when you do this, you get 45 lbs over feet cubed divided by 6 pounds per gallon. Right? And then you would cross multiply. Um, this is a 1, so it's going to be 45 lbs times gallon. And then over here, this is going to be 6 lbs per feet cubed. And so as you can see, the pounds disappear. You're left with 45 gallons over 6 feet cubed. So that's why you could put 45 gallons here and then 6 feet cubed here. Okay, so that comes out nicely. So then you want to solve for x because they're asking for how many gallons. So go ahead and cross multiply. So it's 10 times 45 equals to 6 times x. And then 10 times 45 is 450. Divide this by 6. And you get 45 divided by 6, which is 75 gallons. Okay, so that was just a simple proportion problem. Okay, 17. So an average bath has 8 gallons, an average shower has 6 gallons. In order to provide a bath or shower for 60 people, how many more gallons, so that means subtraction, right? How many more gallons would be used for the two tub instead of the shower? Okay, so that's, yeah, so an average bath has 8 gallons, an average shower has 6 gallons. In order to provide a bath or shower for both 60 people, how many more gallons would be used for the tub instead of the shower? So what I would do first is calculate the total water for baths, right? So we know for baths, there were 60 people, times it by 8 gallons per bath. And when you multiply it out, you're going to get 480 gallons. Okay, step two, I'm going to calculate total water for shower. So it's going to be 60 people times 6 gallons per shower. And you get 360 gallons. Okay, step three, find the difference. So it's going to be 480 minus 360 equals 120 gallons. Okay, so your answer is 120 gallons. Okay, almost there, we're almost done. So let's move on to 18. 18, this isn't a bad one. It says when the temperature is 20 degrees Celsius, what is it on Fahrenheit scale? Use the formula F equals 9/5 times C plus 32. Yeah, this is perfect. So they want to know what is going to be your degree in Fahrenheit, and they give us the formula. The good news is there's no conversion. You just plug in C, which was 20 degrees. So it's 9/5 times it by 20 plus 32. And this is going to give you 9/5 times 20 is 180 over 5 plus 32. And then 180 divided by 5 is 36 plus 32. and you get your degrees in Fahrenheit, which is 68 degrees Fahrenheit. That wasn't too bad. Okay, number 19. A carpenter cut 4 feet 6 inch shelves from 14 feet board. How long of a piece was left over? So this is what's happening. Imagine you have a 3 piece, right? Um, and each piece is exactly 4 feet and 6 inches. And they want to know what's the leftover from cutting it from this this longer piece of board, which is a total length of 14 feet, right? So what we're going to do is convert everything into inches. First step is convert to inches. Okay. So 4 feet and 6 inches. So let's convert that feet into inches. So it's 4 feet times 1 feet, and then you have 12 inches, and you get 48 inches. And then you're going to add, so there's three of them. So yeah, times this by three, and you get 144 inches. Then you also have this 6 feet, and there's three of them. So six times three, which is 18 inches. And you get 144 plus 18, and that gives you a total of 162 inches. Then what I'm going to do is subtract, uh, then let's convert that 14 feet board into inches. So that's easy, right? So to convert that 14 feet board into inches, it's just like this. Feet on the bottom, inches on the top. For 1 feet, there's 12 inches, and then 14 times 12 is 168 inches. So what you're going to do is subtract 168 from 162 from these three pieces of boards, and you get 6 inches. So that is basically what's left over. Okay. Okay, look, we're almost there. I think there's two more. Question 20 says, if 3 raised to the x equals 81, what is x? So you can try, there's two ways you could do this. You could try figuring out what is x, right? So you could just plug in, like, for example, 3 square. Does that give you 81? No, that gives you 9. So that's not. You can just guess and check. The other way is you can put everything in a common base. So this is a base of 3. This is a base of 81. What if I decide to put everything in a base of 3? So what I'm saying is this is a base of 3, so we're good. Over here, how can I rewrite 81 as the base of 3? So what I'm saying is 3 to the what power gives you 81? That'd be 3 to the 4th. And when you have a common base, you could ignore the base, and then you're left with 4. Right? 21. What is 10b minus ab minus 7a? Subtract that from 3a minus 8ab plus b. So don't be fooled. This is not the same thing as this is not the same thing as 10b minus ab minus 7a minus this whole thing. That is completely wrong. I tried that. it was wrong. What it's really saying is like the reverse. It's really saying, so what we're really saying is it's this 3a minus 8ab plus b minus 10b minus ab minus 7a. That's what they're really saying. So don't get, this is very tempting to write it like this, but note that it's backwards. It's really this goes in front minus this. And if it was addition, it's pretty simple. It doesn't matter if it was addition, you can go either way because it's addition, right? But subtraction, yeah. So then I will do is FOIL out this minus, so it's negative 10b. This is going to be positive ab. This is going to be positive 7a. And then bring this down. And then when you collect like terms, let's see, you have a negative 8ab and a positive 1ab. That's going to be negative 7ab. And then you have this 10a, and then you have this negative 10b. Okay, that is your final answer. Okay, last one. Or no, two more, sorry. Okay, 22 says the coordinates of the points A and B are 3, comma 5 and negative 3, comma negative 5. What is the slope? So if they give you 2 points or 2 coordinates and they're asking for slope, you use this formula. M equals y2 minus y1 over x2 minus x1. Okay. So if you have 2 points and they want to know the slope, use this formula. And then what I'm going to do is label this point. So I'm going to label 3x1, 5y1, and then the second one x2, and then the second point y2, right? So y2 is negative 5 minus y1, which is 5. X2 is negative 3 minus x1 is 3. What is negative 5 minus 5? It is negative 10. And then what's negative 3 minus 3? That is negative 6. We know that two negatives becomes a positive, and then this could be reduced by 2, so that's 5/3. Okay, so that is my slope. Last one. Okay, 23 says the factor of 2x squared plus xy minus 3y squared. Yes, you're gonna have multiple choice, but this is how you would do it without a multiple choice, without doing each multiple choice. You're just gonna factor this. And the technique we're gonna use is what's called bottoms up factoring. So why do I do this? Is because when the a value is no longer 1, as you can see, we have 3 terms. My a value is the coefficient in front of x, so my a's value is 2. So how do we do bottoms up? First, what we're going to do is rewrite this problem. I'm going to rewrite it as if the 2 doesn't exist, so it's going to be x squared plus xy. And then instead of the last term, negative 3y, you're going to multiply 2 by negative 3, which is negative 6y squared. And then go ahead and just do factor using simple factoring. So this is x, x, and then what two numbers multiply negative 6 and 1 added gives you 1. It would be 3 and 2. Oh, don't forget, we want a y square, so you're going to have to put a y here, y there. And then I'm going to do a positive 3 and a negative 2 because 3 times negative 2 is negative 6, and then 3 plus negative 2 is positive 1. So that's how I know. And then what I'm going to do is divide the 3y by your original a value 2, and then divide the negative 2y by 2. And then 3y over 2 can't be reduced, so you're going to put the 2 in front of the x. So that's 2x plus 3y. And then over here, the 2's cancel, so you don't have to move it around. This is going to be x minus y. And there's your answer, 2x plus 3y. So this technique is called bottoms up factoring. Okay, I am going to stop here.